Today we are learning about rules of exponents. So just a quick vocab review first. When we talk about exponents, we are referring to these numbers. These are the exponents. If you have a number without an exponent, remember there's always an understood one. You can write it. And when you say the word base, the word base is referring to these numbers. So 7 is the base, 4 is the base, x is the base, 2 is the exponent. So those terms will be really important as you work through this section. And so, as we begin, I wanted to first start off with a couple of examples and then tell you the exponent rules. So, you may recall that 7 to the 5th means 7 multiplied by itself 5 times. So that is a shorthand way of writing 7 times 7 times 7 times 7 times 7. 7 squared means 7 times itself twice. And I have this multiplication symbol in the middle. So really 7 to the 5th times 7 to the 2nd, when I write it out long ways, I can see that I'm multiplying 7 times itself 7 times. So that is 7 to the 7th. And the second example here, I have 4 to the 3rd, which I know from previous knowledge is 4 times 4 times 4. And I know this 4 to the 1, I can write my exponent there, is just times 4. And since that's multiplication, I can see that really that is just 4 to the 4th. And if I do something similar here, I can see that that is x times itself twice. This second one is x times itself 3 times. And so when I'm multiplying this, that gives me x to the 5th. And so in all three examples, you notice that if the base is the same, the 7 and the 7, when you're multiplying, you add the exponents. So here, 3 plus 1 is 4. 2 plus 3 is 5. And so that is just a way of thinking about the first part, and that is called the product rule. And the product rule says if you have a to the m times a to the n, that is equivalent to a to the m plus n. So since the bases are the same, the a's, you add the exponents. So in the second example, a to the 6th times a to the 4th, since it is multiplication, that is a to the 10th. So I do want to point out right here, if I went back and I changed all these multiplication signs and I changed those to addition, this would no longer work. So with addition, I could not do that. So it's kind of a common trick or trap that people can fall into. So let's continue. So right here, a few more examples. So if I have 2 to the 3rd times 2 to the 2nd, again, I know that 2 to the 3rd is 2 times 2 times 2. I know that 2 to the 2nd is 2 times 2. So that multiplication makes it 2 to the 5th. I'm adding the exponents, but you see we have a warning sign. It's again what I was just showing you. If that were addition, that would not be 2 to the 5th. That would be incorrect. Since that is addition, I cannot do that. And so if I were actually asked to evaluate that, I would have to actually figure out what 2 to the 3rd is, which is 8. Figure out what 2 squared is, which is 4. And I could do it that way. Then on this third example here, notice the bases are not the same. 2 and 3, the bases are different, so there is no adding of exponents here. The only way, again, I could simplify that was to evaluate. So the next example here is leading us to what's called the quotient rule. So I'm going to start by writing it out, 7 to the 5th, like I was earlier, which you would not have to write this out every time. It just helps when the material is new and you're learning it. So in the denominator here, I have 7 to the 3rd. And so, since it's all multiplication here, I can do this shorthand. If you look right here, I have 7 over 7. And 7 over 7 is just 1. So those cancel out. Again, here's another 7 over 7, which would just be 1. And 7 over 7, which is just 1. So what I'm left with here in the numerator is 7 squared. So if you notice the original exponents, what I did is I subtracted them. And so that is called the quotient rule. And it says that when you have the same base, the 10 and the 10, you can subtract the exponents. So I will do this one more time. If I had 10 to the 5th, that would be 10 times itself 5 times. So 10 times itself 5 times. And the denominator, I have 10 to the 3rd. Sorry, that looks really bad. 10 to the 3rd still looks bad. Would be 10 times 10 times 10. And so if I were to simplify, I have 10 over 10, which is just 1, so I can cancel those out. 10 over 10 is 1. 10 over 10 is 1, so I'm left with 10 to the 2nd, or 10 squared, which is what I would get if I did 10 to the 5 minus 3. So in this last one, think about that one for a second. That would give you a to the first power. So in summary, what I just showed you is called the quotient rule. And it says when you're dividing, if you have the same base, the a's, they're both the same, you subtract the exponents. So the second example, I put one that is a very common mistake because your brain intuitively, you see this division bar, this fraction bar, and it's really common that you want to see 15 and 5 and divide and say, oh, a to the 3rd, but don't do that. So the quotient rule says since I have the same base, I subtract the exponents. So that gives me a to the 10th. So if the bases are the same, subtract the exponents. So this next rule, before I show you the name of the rule, I want to work it out again. So if I had something like x squared to the 3rd, so I'm going to do the same thing. I'm going to write out what that means. That would mean x squared, all of this, times itself 3 times. So that would mean x squared times x squared times x squared times itself 3 times. And if I use one of the other rules I just learned, that would tell me to add the exponents. So that would give me x to the 6th. Second example, w to the 3rd to the 4th. Well, that would mean w to the 3rd times itself 4 times. So if I were to do that, w to the 3rd times itself 4 times, then I get a problem that's the product rule that we just worked on earlier. So I would look and I would add those exponents and I would get w to the 12th. So the shortcut here, you may have noticed, is from the beginning I had a power to a power. So it was x to the power of 2 to the power of 3. And so what I did there was I multiplied those. 2 times 3 gave me x to the 6th. 3 times 4 gave me w to the 12th. So in summary, the power rule says a to the m to the n, so power to a power, says that I multiply. So an example, 5 to the 4th to the 5th would be 5 to the 4 times 5, or 5 to the 20. So I just want to show both examples real quickly here. So if I had x to the 2nd times x to the 3rd versus x to the 2nd to the 3rd. So I'm just clarifying the difference between the two now that we've seen both of these examples. This I would write out as x times x. This is x times x times x. So that is why I'm adding the exponents to get x to the 5th. The second example would be x to the 6th, because that is x squared times x squared times x squared. So next we have what's called the power of a product. And it says if you have a product, and remember product means multiply. So here it says a times b. Remember there's an understood multiplication there. So if you have a product to a power here, it's essentially that you distribute that exponent. So that would give you a to the n, b to the n. It's like you're distributing the exponent. So for example here, notice this is a product. Everything in here is multiplication. A times B times B times B. So when I distribute that 4, I would get a to the 2 times 4, b to the 3 times 4, which gives me a to the 8th, b to the 12th. The same will hold true, the power rule, for quotients. So since this whole fraction here is in parentheses, it means that this exponent n belongs to both. So again, I essentially distribute that exponent. It's not quite the right mathematical term, but it's the general idea here. So that gives me a to the n over b to the n. I distribute to everything in parentheses. So for example, a to the 3rd over b to the 4th, all being raised to the 3rd power, gives me a to the 3 times 3 over b to the 4 times 3, or a to the 9th over b to the 12th. So if you're feeling confused or like it's a lot, it's normal. I've shown you a lot of stuff so far. And really that's what the homework is for. That's why you get multiple tries, so that you can keep practicing and the homework will help you learn. So, quick warning here, because this is a mistake that I've seen a lot. The difference between these two, you can see obviously the parentheses, but the parentheses are very important. So in this first example here, the parentheses mean that this 4 belongs to both. So this first example is 3 to the 4th, x to the 4th. It's that power of a product. The second example, that 4 only belongs to the x. The 3 has an understood 1. So the parentheses, you have to pay careful attention to the parentheses there. They do matter. And next, we have the negative exponent rules. And perhaps these can be the most confusing. So right off the bat, I'll let you know that you should never have a negative exponent in a final answer. So if you're working and you're working and you're working and you get to your answer and you have a negative exponent, that means you're not simplified yet. And so the rule says if you have a base to a negative exponent, you've got to move the base. So right now, I can make this a fraction. I could put it over 1. So when you have a negative exponent, you need to move it down to the denominator and make it positive, or up to the numerator to make it positive. And I'll show you an example. So for this one, a to the negative 3, and remember there's an understood, I can make it a fraction, put it over 1, is really 1 over a to the positive 3. Because a negative exponent tells you to move the base. So if I were to look at a couple of examples, so if I were to do something that had a little bit more to it, so let me say, what if I had x to the negative 3 over y to the negative 2. So hopefully you remember I just said you cannot have a negative exponent. It means you're not simplified. So what you do is you move it to make it positive. So x to the negative 3 has a negative exponent. So since it started in the top, the numerator, I need to move it down here and make the exponent positive. Y to the negative 2 was in the denominator. It has a negative exponent that is not simplified, so I'm going to move it and make the 2 positive. And it may look strange, but that's all you can do to simplify. You are done. So if you have a negative exponent, you need to move it. So a really cheesy example I have heard, but it works, is if you have a negative exponent, it's unhappy where it's at, so it needs to either move downstairs or move upstairs to be positive. And a final rule, this one always gets people, so if you were asked anything to the 0 power, it is always 1. So if you have x to the 0, it is 1. So here's a bit of an explanation why. If I were to look at x to the 3rd over x to the 3rd, or really anything divided by itself, anything divided by itself is always 1. But if you think about the quotient rule that we saw a few minutes ago, the quotient rule says to subtract the exponents. And if I subtract the exponents, I'd get x to the 0. So that is why anything to the 0 power is 1. So the first blank here, a to the 0, is 1. The second example, since the parentheses are here, it means this entire quantity is to the 0. And again, I just get 1. So here are some examples here that have a lot going on. So you don't have to do them all, but what I would encourage you to do is to take a second, pause the video, work one, and then check your answer with me. So how about we do this one here? So I would pause it, try it on your own, play the video, and check with me. Okay, so hopefully you're just coming back now from pause. So whenever I get something like this, I want to encourage you, because it's what I do, is just to do a little bit at a time. So first I'm going to look at these x's. Here I have x to the 3rd, here I have x to the 6th. And so I think about what that means. That is x times x times x. This is x times itself 6 times. So if I were to start canceling out, I would have 3 x's left in the denominator. So another way to think about that would be to subtract the exponents. If you subtract 3 minus 6, that would give you x to the negative 3, which I would then have to move to the denominator like I did. So the next thing I'm going to do is simplify the y's. Y to the 5th over y squared, which means I'm going to subtract the exponents. It's a quotient. And that would give me y to the 3rd. So if I move on here to the z, I get z to the 1 over z cubed. So if I were to think about this the long way, which is perfectly fine if you want to do that at first. It's a little bit hard for me to draw these z's. But if I were to draw out just the part with the z's, and I were to start canceling, z over z is 1. All I'm left with in the numerator here is just like a 1. And z squared is now in the denominator. So that, right here, that is my final answer.